Okay, that's it. We're done. So let's summarize it. What do we got? The moments of inertia. Okay, the moments of inertia, this is just some of the highlights, right? The moments of inertia only makes sense with respect to an axis. Okay, so you move the axis and all of a sudden the value changes. Okay, that's very important. It's not an intrinsic value of, it's not like mass, right? The mass of something is its mass. But the moment of inertia only makes sense with respect to a given axis. Okay, it can only be positive. We didn't talk about this a lot, but think it's integral of r squared times dA, right? So it's always going to be positive. You have two different kinds of moments of inertia. You have the area moment of inertia. Okay, we're going to use those in strengths and materials. It turns out you're going to learn this next semester or next year when you take more classes on this. That's going to be used to determine strengths of various shapes of beams, columns, etc. Right? But we also have the mass moment of inertia, and that's what you're going to use in dynamics. It's kind of a measure of how hard it is to rotate things. Now you'll notice I just said that moments of inertia, when you move the axis, the value changes, and then I said it's not like mass. But yet here in dynamics, I said it is like mass. What's the difference? Well, still, when you're trying to rotate something, think if you're trying to rotate, anything, an object, the further away you are from that object, it changes how hard it is to rotate that. And so that's going to be the mass moment of inertia. We also talked about the product of inertia. Now, the product of inertia is relative to two axes. Okay, so the product of inertia is with respect to two axes. Now, if one or both of the axes are an axis of symmetry, the product is 0. So don't make your life hard. Look at it. If it is symmetric, just call it 0 and call it a win. Walk away. So don't try to calculate things that you don't need to calculate. Product of inertia can be positive or negative, right? Because it's integral of x, y, dA. And so if you can definitely have a positive and negative values of product of inertia. And then we talked about the parallel axis theorem. The parallel axis theorem. The most important part about the parallel axis theorem is it can be used for moment and product of inertia, but it's only valid through the centroid of an object. Please, please, please do not make the common mistake of using the parallel axis theorem through any point other than the centroid of the object. So that is this chapter. Let's start on the homework and see how things